All right, let's get into calculating enthalpy change. So I'm going to show you one method in this video, and I'm going to show you another method in the video that's following this. So what I want to talk about in this video is something called Hess's Law. So Hess's Law, it says basically I'll just read it. If a reaction is carried out in a series of steps, delta H is going to be the overall reaction will equal the sum of the enthalpy changes for each of the individual steps. So it shows you all this craziness going on here. We have methane and oxygen, partial combustion, right? So this makes carbon monoxide instead of carbon dioxide, right? Make some water, you have a little bit of oxygen left over. The oxygen and the carbon monoxide react further to give you carbon dioxide in this. So let me just kind of rewrite this. All right, so that first step, methane, oxygen, making carbon monoxide, water, and then there's a little bit of oxygen left over. All right, it said that delta H was negative 607 kilojoules. All right, so it releases 607 kilojoules. The step after that, this one right here, right? You had the CO and the oxygen making CO2. That was 283. So what Hess's Law is saying is that if I can take this equation plus this equation and it equals this equation, then this delta H plus this delta H equals the delta H of this equation. All right, so when I add these equations up, we can add equations, right? So what I do is I take all of my reactants, just copy all those reactants, put them all on this side of the arrow. Take all of my products, put them all on this side of the arrow, and then cross out anything that's the same on both sides. So the other method is actually the way I do it, is I cross out things before I add them. So if I see something on the product side, like CO, and then I see it on the reactant side, boom, boom, take it out. Half O2 goes out. So the only things left in this reaction are CH4, O2, CO2, and the 2H2O right there. So this equation plus this equation equals this equation. So that means that this plus this has to equal this. Right? This works because delta H is a state function. Right? There's something called a state function. State functions only depend on their current state. Right? So if I'm doing delta H, that only depends on the initial state and the final state. Right. So let me just kind of tell you about state functions really quick, because I know at first, like, state function, that just sounds weird. But again, it's just something that depends only on your current state. If you're in a building, the floor you're on would be a state function. So let's say you're on the 4th floor, all right? So your floor is 4, right? You're there with your friend, yay! Let's do delta F, right? The change in the floor. So if I jump on the elevator and whoop, I cruise up there, right? My friend, workout fanatic, wants to run the stairs like crazy. Goes crazy up there. Let's calculate delta F for both of us. All right, so my final floor is 8. My initial floor is 4. 8 minus 4 is 4. How about this guy? Same thing. Same delta F, all right, even though the paths taken were totally different. So what is different would be work. Work is not a state function. All right, me being on the elevator, I didn't do a lot of work. My friend running the stairs did lots of work. Work is not a state function. Heat's not a state function. But enthalpy is a state function. All right, so what that means is it only depends on the initial and final states, not how we get there. We're going to use that to our advantage in the next lecture, because we're going to just make up a way that a reaction is going to take place. It doesn't matter that it actually, whether or not it takes place in that way, because we're going to start in one place and end up where we need to be. So how we get there doesn't matter. That's because it's a state function. All right, let's get to this. Let's get back to Hess's Law. All right, let's say I have these two equations. So I have NH3 plus 1/2 N2 plus 3/2 H2, like fractional coefficients. Weird. You're going to see that in this chapter, though. All right, and then I also have 2H2 plus O2 goes to 2H2O. And I have the enthalpy changes for both these reactions. So these are thermochemical equations. Cool. And I asked you, all right, what is the delta H for this equation? All right, these are like puzzles. These are like Sudoku. I actually really like these things. They're fun. They're kind of like challenging sometimes if you have a really crazy one. This example is not too crazy, but here, let me just flip to the next slide. I was going to spit out all the rules here, but I have them on a slide, so let's just read them. All right, so we're going to work backwards from the required reaction. So I call that my target. All right, so I have this target equation, right? And I want to do something to the given equation. So I was given two equations, right? What I want to do is flip-flop them or multiply them in such a way that when I add those equations up, it equals my target. All right, so if I take an equation and I reverse the equation, what does that do to delta H? It flips the sign, right? If I multiply all of my coefficients by a number, what do I do to the delta H? I multiply by the same number. All right, so those are the rules. All right, and I want to do that, so I want to take these equations and manipulate them in such a way that when I add them up, it equals my target. And then if I've been keeping track of my delta H's, I just add up my delta H's and it will equal the delta H of my target. All right, so let's kind of go back to this thing and see what I'm looking at. All right. All right, let's see. Whoop, hold on. All right, sweet. I'm back to the slide I want to be at. I was like, oh, it's already been flipped. All right, so this is what I was given. I wanted to come back to this slide because this is what I've actually been given. So the two things I want to do is I want to check that things are on the correct side and I have the correct number of them. So I have the coefficient that I want and it's on the right place. So I just kind of like look at stuff. I look at things and I go, okay, where do I see whatever? And like what's popping out to me right now is I see NH3. Like the only place I see NH3 in my given equations up here is right here. All right. In my target, it's on this side. So is this on the right side? No. I need to flip this thing around. All right. So this whole equation needs to get reversed. When I do that, this delta H becomes negative 46. The next thing I'm going to do is I need to multiply this equation by something to get the right coefficient. I want a coefficient of 4. All right, so when I reverse this equation, right, this has a coefficient of 1, but I need to multiply everything by 4. So times 4, times 4, times 4. So what do I do to my delta H? I multiply by 4, right? Once you've flipped and multiplied, you're done with that. Like you've done everything you can possibly do to that. So I'm going to move on to this next equation, and I see what just jumped out of my face right there is I have 2H2O right here. I have 6H2O right here. All right, again, H2O, the only place to see it is right there. All right. Is it on the right side? Is it on the correct side, I should say? It's on the right side, but it's not on the correct side. I want it on the reactant side. So I need to flip this equation. So if I reverse this equation, all right, this becomes a plus 484. All right, so now it's on the correct side, but do I have the correct number? No. All right, this equation, it's 2H2O, 1O2, 2H2, gives me this. I need 6H2O. So I'm going to multiply all these coefficients by 3. Times 3, times 3, times 3. And then what do I do to this? I multiply by 3. When I do that, hopefully like this plus this will equal this. So let's cruise forward to those slides. All right. So we flipped. So that's the reverse. And so we change the signs accordingly. And then I'm going to multiply. All right. So times 4, times 4, times 4. So I multiply that by 4. Take this one, 3 times 2. 3 times 2, 3 times 1, and then times 3. All right, so when I add these all up, so when I kind of run that all through, blah, 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 come on. All right, so now I've multiplied and flipped. Right, when I add these guys up, you see the 6H2s cancel out, and what do I get? I get 2N2 plus 6H2O, right there. Reacts, and they produce 4NH3, 3O2, right there. So this plus this equals this. All right, so this equation plus this equation equals this equation. So here's Hess's law. That means this delta H plus this delta H equals this delta H. Boom. All right, so that's how I do one of those equations. We can work some more of these in class because I know it's kind of weird to see in a video, but they are kind of fun. Once you get used to them, they're pretty fun. They're like little puzzles. All right, we'll stop here.